I like how the voice comes on there to announce that. How's the view?
All right, I think we can get started. So the next speaker is someone I've known for quite some time now. If you're in DG, you should already know him. His name is Tal, software engineer slash data scientist slash entrepreneur. Today, he's going to talk more about real-world AI. Without further ado, let's give it up for Tal. Stage is yours.
Thank you very much, Ryan. So I'm going to be talking about real-world AI today and kind of how tech intersects with life. And when I was asked to give this talk, I gave some really serious thought to what I could say that would be impactful and useful to you guys. And considering that I was, in your shoes just a few years ago, what I was really asking was, what could I say that would be impactful and useful to me, right? So this, by the way, was my first hackathon here on the right. You can sure figure out which one I am. Ugly one right there in the middle. So I want to see what I could say to a younger version of myself that would help shape my exploration of tech and machine learning and school and careers in a positive way. So essentially faring off the idea that if you're starting out with wherever you are, with a few dreams, what would it take to get you to where you want to go? And so the structure of this today is going to be, we're going to go through 4 questions that I came up with that kind of were really things that were riding on my mind when I was going through school and wondering all these things. Questions that I think kind of really highlight the uncertainties in going through the process of, going from, what back in high school to, I'm going to be a professional in tech somewhere. And so we're going to be going through these questions, and I'm going to be giving at the beginning there a bit of a kind of my journey, my path here. So first, here are the questions that I think really matter here, which is, well, one, in school, what are you going to do with your life? No one tells you this, right? It's an impossible question to start asking questions about. And to be honest, it's like, it's basically code for what's the meaning of life. It's a huge question. So we're going to go over it with a little bit. And then the second one is, can I start a startup? Is it something reasonable to do? Is it something possible to do? Third one is, what can I do now to get me there? And then the fourth one, which I think is one that's kind of riding on a lot of your minds, especially at this phase in kind of the end of your education, the start of your career, is like, when am I worthy? When am I ready to stop being, some CS student and start being like a software engineer, Like, at what point have I earned that title? And so to start here, I'm going to talk a little bit about myself and kind of talk about my trip. And funny enough, it did start with a trip. So when back in 2016, I had just finished high school in New York State, and my sister had found really cheap flights to California. I'd never been to California before, and she said, "Oh, come on, let's go." And so like, I was convinced. We went together. I spent 2.5 weeks in LA, a week and a half in San Francisco. I flew back to New York, and within 6 months, I'd moved to California. So this, like, it's a really defining place, this one. And on that trip, I had a number of firsts. That was the first time that I'd been, alone without my, this was high school that I just finished. So first time I'd been without my parents, 2,500 miles away. First hackathon. So this was a project called Book Music. We were trying to generate soundtracks for books using essentially natural language processing. We got very, very little done, and it was a shameful project. And yet that started a hackathon career that went on to like 30 different hackathons. And so ultimately, I think that there were a few really interesting lessons that were learned there. And one of them is, if you come to this place, you have a career in front of you, right? If you come and live in the Bay Area, this is where everything is happening. This is where you can come and be part of something big. And so I moved to California. I was in school here. actually in school physically there at DG, though it occurs to me that most of you guys are checking in from your homes, and I wasn't there. That would be creepy. So we were part of DG, you know, back kind of when it was like the previous generation of students. And as I was going through school, you know, year after year, one summer I had a company reach out to me and say, hey, we want you as an intern. And I, you know, said, yeah, that sounds great. You guys are amazing. Let's do it. And then at the end of the summer, that led to them asking me to stay on as an employee. And then I stayed there, and that was, you know, my first programming job. I spent 3 years with that company. And then about 2 years ago, I happened to stumble into this biotech lab because I showed up at the wrong meetup, and I found out about halfway through the free pizza that this was a biotech event and not a tech event. And so I said, well, I mean, I guess I should stay now. And, you know, so I sat the thing through, and turns out that biotech is really fascinating. And I met a group of friends and started joining projects and getting lab time, picking it up as a hobby. Fast forward, you know, to 1 year ago, hundreds of hours of lab time later, I've got a group of friends that we've been working on this project for the longest time, and everything is like failing miserably because biotech tools suck. And I think that just about anyone who's got experience in the field will agree, like the tooling in biotech is absolutely miserable. And yet there's no technical reason why it has to be miserable. Like honestly, the tooling could be better. And so the group of us said, you know, what if we just started building tools, and we spent months building our own little tools that we would use until we realized that, you know, the tools that we had made, other people wanted to use them as well. And this was when a conversation happened on, hey, should we turn this into a company? Should we, you know, take the things that we've been building as a hobby for the past few months for the biotech field and start getting customers and start doing it? And so we did. And that was at the end of last year that we kind of made this big transition. And then since then, I've been full-time at this startup. And things are going really, really great. We found someone to, you know, give us a little bit of capital so we could get our feet off the ground. And, you know, of course, then the zombie apocalypse started, which was an interesting ride to try to start a company while the lab is shut down for biohazard reasons. But this is kind of the journey that got me here. You know, 3 years in at a tech company working on data analysis and pipelining and building tools to make what people do more efficient by squeezing every last drop of juice out of that data that I can. And then now starting on a biotech company, doing largely lab automation and you know, clever algorithms to try to cut out steps of lab work and save time and money for people. And so this is the trip that I took, you know, kind of over the past several years, and very few of the steps were thought out. And I think this is kind of a big lesson for me, was that you think that you're going to plan a path and then go down it, but if you don't make sure to do that, then what ends up happening is you just kind of, you know, you follow the path of the default. And so if you actually want to make sure that you can have, you know, whether it's the career that you want or the family life you want or whatever you want, then it takes asking a few questions, asking them early, and then committing to the resolution that you'll shape the answers in such a way that you arrive at what you want. So this leads us back to our 4 questions. So what am I going to do with my life, right? Can I start a startup? Should I start a startup? What can I do now to get me there? Whether it's startup or, you know, company, corporate, whatever. And when am I worthy as a software engineer? Oh, we forgot something. We have to close that tag. There we go. All right, back to the questions. So first, let's start with what am I going to do with your life? Now, there are way too many options to fit into, you know, a short slideshow. So we're going to be talking over the main ones in tech. So leaving university or college or whatever it happens to be in your case, there are 3 paths that you can go down. I mean, there are a few more, but these are the most common 3. You can go down the corporate route, finding a job at some major tech company, or some major company that's not a tech company that happens to really need software engineers. Or you can go down the freelance route, which is where you essentially act as a one-man company, doing little jobs for any number of groups or people or small businesses and so on. Or it can go down the startup route. And each of these is I'd say, a great option for a certain kind of people. But what's interesting about this is that the steps that you can take to prepare yourself to be really, really successful kind of at this point in your life depends on which of these three routes you want to choose. So we're going to take a really quick look into all three of these and kind of what their pros and cons are. And then hopefully with having in mind what the journey that you want to go down is, we can start talking about how you get there. So first, you can go the corporate route, right? This has a number of interesting pros. So for example, if you show up and you do what's on the Scrum board or the Kanban board, whatever that you guys happen to be using, as long as you follow the instructions on the board, like you'll get your paycheck at the end of the week and everyone will be happy with it. It's also usually pretty easy to figure out what you have to do because there's always someone above you with a list of tasks. And ultimately, there's very little risk. It's comfortable. I'd say that out of the three options, corporate is by far the most comfortable. On the other hand, you're like a little part of a very big thing. You ultimately have very little impact, depending on the size of the company, of the actual direction of the company. And oftentimes there can be decisions made that you disagree with. You may not really enjoy the projects that you're working on. Sometimes you'll happen to have projects that are interesting. Sometimes you'll happen to have projects that are not. Typically, the longer you're at a company, the more say you get over which projects you end up with. But this, lack of choice for a lot of people can be disconcerting. And then finally, you tend to get very locked in terms of what skills you work with, right? If you're working on some like front end project and you happen to really want to try out some new technology or something that's like some machine learning thing, you can't just like throw machine learning in there because you want to try out machine learning. I mean, you can, but your career is going to not last too long. So ultimately, what it means is that you're going to be restricted by the whims of others. But if you're kind of willing to accept that, then you can have yourself a pretty great career trajectory. If you're willing to kind of eat those cons. Next up, there's the option of freelancing, right? Now, freelancing has kind of exactly the opposite situation. So you control all the hours, you control the workload, like the tech, the stack, and so on. Within, of course, constraints given to you by your client, like, if it all has to run in this server or that thing or whatever, and they tell you that those are the requirements, then you kind of have to fit the requirements, but you control everything otherwise. And this is probably the biggest one. If you are the kind of person who can motivate yourself, your success scales directly with the amount of work that you put in, which means that if you work, really hard, if you do 18-hour days, then you can earn twice as much, do twice as well as the guy who's working 9-hour days. And then finally, there's a constant onslaught of new projects, right? And by impressing people who you're working with, you can often kind of stay on the projects that you enjoy working on and then drop out of the projects that you don't really like working on as you get more and more experience, right? So the ones you don't like, you can finish it up and tie a bow in it and just say, that's it. And then continue to engage with the client if it's something you want to keep working on. So you do have a good bit of control over even what you're building. The problem is, ultimately, there are a lot of skills beyond the tech that you're going to have. You're going to have to be able to brand yourself, sell yourself, social media skills, business skills, legal parts kind of kick in here. There's like finance skills. There's a lot of stuff here beyond the tech that has to get done. And if that's not your cup of tea, then that might be a non-starter right there. And then, of course, if you don't find the clients, then your bills don't get paid, which is a concern for most, I'd imagine. There's no such thing as paid time off, right? You get compensated for what you put in. You don't get compensated for what you don't. And you'll notice that I highlighted this one last point down here at the bottom because it's particularly important. when you're at a major, when you're at a company that has, I don't know, 50 or more people, you are surrounded by people who really enjoy what they're working on to some degree usually, and can offer all kinds of skills and perspectives that you don't have. Essentially, a big company done right becomes like a family. And when you're freelancing, you don't get the family. It's just you. And depending on your mentality and how well you work with or without others, this can be a very big thing for some people. And this is, by the way, one of the big reasons why I never I never seriously considered freelancing. And then there's a final option on the table, which is the path that I went down, early stage startups. So you control everything, which is great, but also you control everything. So if anything goes wrong, it's your fault. If you do things right, then the options are amazing. You can go down a path that, think of it this way. Facebook was a startup once upon a time, right? So the potential on the upside can be fantastic. The potential on the downside is you bankrupt yourself and accomplish nothing. So it's obviously not without risk. But I think what really got me on this one, and I'm going to spend a second talking about this just because it's such an important idea here, is you can impact a startup to a much greater degree than you can impact the world through a startup to a much greater degree than you can either as part of a large company or as a freelancer, right? And if you as a person, and I'm saying this because most of you guys, or all of you guys potentially, are right now in school, still in that mindset where you're trying to figure out what you want to do, not really sure what's going to happen when school ends. Frankly, the world's on fire. Who really knows what's going to happen next week even? Actually, also there are elections next week. Really, who knows what's going to happen next week? When you're at that point, then it's very important to start giving this some serious thought. And if impact is something that really does it for you, if that's the kind of thing that motivates you, then I will tell you that there is probably no tool on the planet that can make more of an impact than starting a company or terrorism. But that's probably not the kind of impact you want. So, and then finally in the negatives, we have that, frankly, you're going to make a lot of mistakes if you go down this route. Like, you're going to make a lot of mistakes if you go down this route. And those mistakes are going to hurt, and you're just going to keep making them, because every single thing you do is going to there's going to be new components in there that you've never encountered, or new skills that you've never needed before. And, it's kind of soul crushing. But if you can, as it was said by a pretty well-known Silicon Valley entrepreneur, if you can kind of get through the chewing glass and staring into the abyss, then you can do something that means something. So that's kind of the first question right there was, what do I do? Question two is, well, can I start a startup? And I think my opinion here. Well, first of all, yes. But second of all, it's a lot. And I think that there's a big habit, especially around here, of kind of glamorizing a process that's really ill-defined and has very significant downsides all throughout. I've been asked by a number of people kind of my perspective on starting companies and how to build something that that survives. And the true answer is, you just fight through it. After every single thing that happens, you just keep fighting and fighting and fighting and fighting. And so this whole, it's almost a facade that exists around the idea of starting a startup, where people say, oh, this would be amazing, and then I'll do this for 3 years, and then I'll sell it to Google for $1 billion. That's not going to happen. But furthermore, the process is so poorly understood, because the only startups that you hear about are the ones that succeed. You don't hear about the three friends who sat in a garage 6 days a week for 2 years to try to build something, and then they got outcompeted by someone else and gave up. And they don't make the news. The only ones who, even the really early stage startups that you hear about, have already made it past some of the hardest parts of the whole thing. which means that you really don't get a full picture here. So what is it actually like? Well, and this is kind of where we're getting into a little bit of what real world AI looks like. Is I remember taking classes on this and hearing like, you know, hey, like you can build all these really amazing models and do so, like, you know, fantastic stuff, solve problems that are really, really hard to solve using, you know, like conventional algorithms and so on. And what, you know, it actually looks like, at least on the tech side, is basically you're spending a lot of time like building weird like pipelining and stuff. You know, you're like, you have various bits of infrastructure that you have to make just in order to be able to even get into the fun bits where you're making a model. You know, you have, I'll give you an example straight out of our lab. We had a model that we were working on about a few weeks ago, where we were trying to identify organisms using a microscope with machine learning, right? So it's images. It should be like really, really easy. Like it's a solved problem. Now, we spent probably about 6 hours working on the model that identifies the organism. And then we spent about 3 days getting the microscope to interface with the computer. And then we spent 4 days getting the slide ejector to interface with the computer. And then, so overall, we spent more than 2 weeks on a project where only 6 hours of it was actually building out the machine learning model. And this is kind of what machine learning looks like in basically any context where you're not at a huge company where you have people above you telling you, like, you know, handing you all like your perfect environment to work in. If no one else is building the workspace for you, then not only are you responsible for doing the job, you're also responsible for building your own workspace. And especially in the startup world, this provides a lot of extra work. And then there's another side here, which is often forgotten, which is, you know, early on, you don't really have like cash to spare within a company, right? So you're stuck in a position where you have to choose between the company surviving a few more months and you eating better food, or like eating at all. So these kinds of decisions are like, they're real, and they're the kinds of things that you don't really think are happening in like Silicon Valley until you look behind the covers of a lot of this stuff. And then, of course, there's the failure, the constant failure at every single point of the thing. Like every single challenge that you will face, you'll typically fail on somewhere between like 1 and 20 times. And then the next time you encounter the same challenge, you'll fail maybe twice. And then the next time you encounter it, hopefully you'll succeed right away. And this is kind of the art of starting a startup, is failing so many times that there are just no mistakes left to make. But then we haven't gotten into the positive side here, which is more what you know, what the tech end looks like when you have everything going right. And this is we have between us a mechanical engineer, a computer science student, a biomolecular engineer, and a data scientist. And we have managed to put together, at this point, an iOS app with no one among us having any previous iOS experience, an Android app, same situation, a crypto component, which was entirely a waste of time and involved learning crypto for no good reason, and interfacing with everything from billing to taxes to shipping APIs. And all of this was built by 4 people in under a year, to the point at which we can get a new order, and very soon we'll be able to push out, essentially do the entire fulfillment process without any human being involved, just like automated factory. And this was like, it was a challenge to put together, but this is what you get when you have a whole bunch of people together working on you know, working in an organized fashion on making something amazing. And I can take very little responsibility for that. Frankly, most of the work was done by people, you know, my co-founders, who are much smarter than myself. But the end point of when you realize that you've built something that you didn't have before and that didn't exist, that no one had before, and you put it together yourself and with a few friends, that feeling, that I think is the success that makes all of this worth it. So now that I've gone through making you utterly depressed about startups and probably making you reasonably depressed about corporate, for those who still want a career in the tech industry, what should you do? And I'll spend a minute really quick kind of like popping the bubble that I've been inflating over the past few minutes, which is I would say tech in general tends to be overhyped. And the result of that as a field is that you hear a lot of the positives and you very rarely hear about the negatives. And so one of the things that I think would have been really important to a younger version of myself, you know, that hackathon photo from way back at the beginning, to hear is that essentially there are downsides and recognizing them is really important, but I would still say they're all worth it for me, and they're probably worth it for most of you guys as well. So if I haven't been able to break your spirit enough to convince you not to go into tech, then the first thing I'd recommend you do to start a career in tech is start building things now, like immediately. Whenever there's something that you want to use that you can't find that someone else has built, if it's something that you reasonably think you probably can't build, try building it. If you think, oh, that would be easy, definitely try building it. Because you'll be proven wrong and the rest of us can sit here and laugh. If there's something where it's kind of this long-term project that you'd like to eventually be able to build, put it in the back burner and see if at some point soon you reach the level of skill needed to make it happen. So I would say building things is probably the single most important thing you can do towards both getting experience working with what it actually looks and feels like to be in tech. And second of all, building up, honestly, a portfolio that you can then show off. Because as a student, someone without professional experience, you are going to be judged for your lack of professional experience. And having something like a portfolio of projects you've built yourself is probably the single most effective way of getting past that. Two, meet people. One of the more kind of interesting lessons that I learned as I got older was, when I was in high school and especially when I was in college, I had no idea why anyone does networking. Like, it made no sense to me. Like, you meet someone and then hopefully you happen to find someone who's exactly what you're looking for. The whole concept was very alien to me. And then I joined the professional sphere and I realized that networking has a very, very real purpose, which is that you tend not to find things you're looking for through, like Google and the internet or whatever. You tend to find things that you're looking for through people. You'll run into someone who's built something, or you'll run into someone who has a friend who knows someone who's built something. And because people are the way that you find just about all the most useful things that you will need at some point in your career, networking, reaching out, making friends is probably one of the most important things that you can do. And then also, at some point you're going to have hopefully a big, rich connection of, by rich, I mean, deeply connected, I don't mean financially, group of people who you can reach out to, forming a very large and useful network. And I would say at that point, you can, keep networking, share the network. Third, is I would say learn as much as you possibly can. So this one would seem obvious at the start, except I think school has a habit of teaching you to learn the wrong things. When I was in school, we were learning specific concepts that we needed to pass the test, and then we were essentially forgetting them as soon as the test went by. Except unless you have a cumulative, in which case everyone would just dislike the professor. The problem is that you're not really learning for the goal of increasing your level of skill, and you're not really learning for the purpose of being more marketable. The goal here is to pick up skills that you can then have that no one else has. Because as soon as you have these, suddenly you become valuable to someone else. And if you want to go the startup route, they become valuable to you. So I would say make a habit to identify the skills that can benefit you in the position that you're in, and take every possible effort to learn as much as you can. Impress people. So like excuse me, like we were saying with make friends, like we were saying with make friends, most of the things that I hope we're not having some technical difficulties here.
Corona.
Yeah, definitely. I've got the Rona, guys. Sorry, give me a sec. All right. So I said that most of the things that you will need to find as part of building your career, you will not find through Google. You'll find through people. And a lot of these people are going to be standing in your way at various points in your career. I would say that gatekeepers are, it's a kind of an unrecognized truth of any industry, but especially unrecognized in tech, is that there can be a position or like a project or whatever that you are perfectly well suited for that you will not end up getting because the wrong person wasn't impressed. And so the general practice that I try to use as my mentality whenever I'm working on a project is look around at all the people who are also working on this project. Your goal is to make them look as good as you can, because it's gonna pay back in droves the benefit from making other people look good. Plus, it's a good thing to do as a human being. And then there's one last thing that I would think is probably the biggest tip that I can give to students, as kind of as the response to what can I do now, which is take chances. And I think I didn't do this nearly enough. Most people probably don't do this nearly enough. Being in school at this point, not being dependent on your own income, having a lot of people with similar interests around you, and having a decent amount of spare time to build things, I would say that this is an opportunity that you're very rarely going to have in life, to, as an adult, have essentially everything you need in life provided for you and spare time to do whatever you want. Instead of using that spare time to binge Tiger King or whatever, taking that time and doing things. Who knows? Like start a startup. Go on meetings with people you've never met from across the world. Like take chances, basically. And it doesn't have to be professional chances. It just means there's very, very rarely going to be a position in your life where you can better take chances. And I would focus on doing that at least just a little bit more than you are. I know that I would have if I could have gone back and changed it. And then kind of for the final question that I'd like to address here, which is the biggest thing that I think I struggled with making the transition from school to professional, is at what point do you stop being a student and start being able to call yourself an engineer? And there are a bunch of different ways of asking this question, but the simplest and most a kind of heart-wrenching way of saying it is just, when am I worthy, right? Like, when do I deserve that title? When do I deserve to, when am I employable? When am I worth someone, going out of their way to bring me in to build something with them? And there are a few different answers to this. Answer one is, well, when you get this title, then you're worthy. Or when this company appreciates you, then you're worthy. Or any number of outcome-based ways of doing this. But to be honest, none of these are particularly helpful, because the fact is all of these outcomes are largely determined by randomness, right? There's going to, you decide that you really, really want to work at, some major company that will remain unnamed. They happen to not be looking for your position at the time, right? Nothing you can do. It's just, the stars didn't align. And so these kind of outcome-based determinations of when am I worthy is just not helpful, because you're going to be basing your answer to that question more on luck than on anything else. The better way to do this is to look at what you're doing, like what you're capable of, and to say, well, what can I do right now? What have I done? What have I built? And to realize, as I did, back at that hackathon, way back in the day, that ultimately, and like you don't really no one tells you, hey, you're ready for this. No one walks up to you and says, hey, you're professional level now. You can work here. I mean, like, if they hand you a job offer, then that's, I guess, about as direct as you can get. But no one will judge you as a human being and say, okay, you are ready, or no, you are not ready. And this is entirely up to you. And if I go back for a moment to kind of my experience with the whole thing, as I'm struggling with me here on the right. So at this hackathon, I showed up by accident. I did not know that there was a hackathon going on, and that day I hadn't applied for the hackathon. I happened to hear about Galvanize and walked in one day while I was on that trip visiting San Francisco. And there was a hackathon going in, and I said, ooh, can I take a look around? And they said, are you planning on joining a team? And then I said, well, I mean, if you offered. And that was the start of my hackathon career. No one will walk up to you and say you're ready. The truth is, you'll just see an opportunity, and whether you're ready or not, call it worthy or not, is not based on what you can do. It's based on what opportunities you take. And so as an answer to the question, when am I worthy? All I can really say is, it's when you decide to be. So that kind of goes through most of what we have today. And then I also have a number of different little stories and questions that I can answer as far as the tech, as far as the AI component, which got a little bit overshadowed with the life advice here. So we're going to open this up for, I guess, 15 minutes for some questions, and then we're going to continue from there. So for now, thank you very much. And if you've got any questions, then your MCs over here, I guess, can handle that. I think you guys are muted, by the way.
So thanks for sharing. Really appreciated that. One of the things I was curious about, amongst a lot of what you discussed, was I think you mentioned a hackathon career of some 30 hackathons. I'm curious, over what time span did you participate in all those?
So that was probably about 2.5 to 3 years. At one point, I was really obsessive over it, and I'd go to 1 or 2 a month. I had a period of a few months where I had, there was a school holiday that got extended for technical reasons. And I spent the entire time driving from state to state to state, trying to catch all the hackathons that I could. And so yeah, pretty short period of time. But the lesson that's learned from this, I think, and in my case at least, is that going from, hey, I'm in this place where people expect me to build things and what do I do now, to, hey, I can do this. I know what this is like. I am capable of this, was really not a matter of learning skills. It was more a matter of just realizing that you're already there. And I found that to be the case with most people who started the hackathon experience. Anyone else? No one wants to ask the juicy secret sauce AI questions?
I have a question.
Yeah, sure.
I was wondering, how was your first hackathon and how did it go?
Sure. So my first hackathon, I arrived a few hours after it started because I didn't know that it was happening, But so there was a team of, basically I was walking from table to table trying to see what different people were working on. And there were all these interesting ideas. And there happened to be one table where they mentioned this idea of, hey, we're trying to make, books need soundtracks. Movies have soundtracks, and that's why they have such a great emotional punch. What if books had soundtracks? And so what they did is they made an e-reader app, where they were working on trying to make an e-reader app. that would analyze the text in real time and pull up kind of emotionally matching music. And so at the time that I happened to walk by the table, one of their folks had just like left the team, and I heard them saying, "How are we ever going to find another person who knows Node.js?" And that was probably the moment at which I realized, hey, I actually have a chance to like jump in here and do something, because I can Node.js. That was like the only skill that I had back then. And then so we sat, we went through the whole thing, and we had a bunch of different pieces that had to be made. We had a reasonable sense of how we were splitting up the pieces. To be honest, everyone clobbers over everyone else, like always when it comes to these hackathon things. I've never really been to a hackathon where you totally successfully manage to distribute the work and not have someone stepping on someone else's toes. So, definitely something to be expected, but usually it's pretty easy to resolve. And by the end, we had all these different pieces. We had to like kind of connect them together. We were running out of time. We connected almost all the pieces. We left like there was one feature that we wanted to integrate that we just couldn't integrate in time. And so we just kind of left it out and felt sad about the hours of caffeinated binge that we had put into making it work. So they went, like the judges went around, and if I remember correctly, we didn't win anything that first hackathon. I went to another one maybe 2 months later, which was the next one that I found after returning to New York. And that one I like had a sense of, I think I know how we can do this like more efficiently with time. And then that was the first one where I won anything. And then you kind of, start to figure out the strategies to get better at, actually winning things at the hackathons as you attend more and more. So the first one, I remember it fondly as a great experience, even though, to be honest, we like the code was really ugly. We were half awake as we were presenting. I actually think one of the 4 team members fell asleep like right before the demo. So only 3 of us like presented it because we had been up for like 36 hours at that point. So the like hackathons will be a mess, and you learn to love and appreciate the mess. It's like, it's like, fond memories where things go wrong, but everything still works out at the end. Hope that answers the question.
Yeah, it did. All right. Thank you.
Yeah. What else?
I have a question.
Mhm.
I guess I have 2 questions. So, like, for a startup in AI, how do you, I guess, compete with companies that are able to afford to train like extremely large networks, neural networks, when like just starting out, we don't really have that computational power?
Yeah, that's a fantastic question. So with AI startups, the best answer that I've found to that one is be more niche than everyone else, right? So you don't really want to be competing upfront head to head with a company that can, out train you. Because to be honest, training's expensive, especially when you're, working with like, big collections of data, images, and so on. And so if you are trying to do something and there's another company that's doing the same exact thing and they've got a lot more funding than you have, things are going to be really, really, really hard. However, if you start off by finding a niche that, let's say some sub niche, some subcategory that they're either not thinking of or intentionally ignoring, and you focus on them. And I'll give you an example actually to be a bit more concrete here. So let's say that you're working on like a Khan Academy kind of thing, where let's say it tries to figure out what you've learned and what it should teach you next, right? Now, there are probably a number of companies, including Khan Academy, that are working on identifying what you've learned, figuring out what content to deliver to you next to kind of fill in your blanks. So that's a problem that you're going to be competing with some like big players on. Like, Google's got something there, OpenAI has something there. It's a hard game to play. However, there happens to be kind of a smaller game that you can play that's a much easier one to get into because no one's really thinking about it, which is instead of teaching people facts, there are right now special education programs that are trying to teach basic social behavior, right? And these programs have been very, very successful by training behaviors that would normally, for neurotypical individuals would come naturally. For people who, let's say, are on the spectrum, have to be taught. And there are some very successful programs doing this. They are very, very people intensive, and so if they could find some way of essentially figuring out whether you've learned a social skill correctly, it's a very similar technology that you'd have to build, except it's a different market entirely that you're targeting. And it stands to reason that almost no one else is targeting this problem for special education. And so oftentimes just by going a bit more niche, you can greatly increase your competitiveness. And then eventually you can kind of take a step back and focus on the broader market. It's, so start off on something really specific and then broaden over time. And that's, as you get better funding and learn what you're doing, and puts you in a better position to compete. So that's a strategy we've done. We're in touch with a number of other startups that, kind of we help each other at various things, as the need comes up. And it seems to be the move that basically all of the successful startups that we've kind of got semi-partnerships with have done, is this start out niche and then broaden strategy. So I can recommend this one, and I'm sure there are others.
Do you use transfer learning? Do most startups use transfer learning, or is there like a legal issue with that?
So a lot of transfer learning is oftentimes it's like open source, you're fine. Whenever things are released publicly by big name companies, oftentimes they will either open source it or they just won't release the weights, for example. They'll release like the model structure, but they won't release the weights. In which case, you're just kind of stuck retraining it. So in general, if the weights are available, you're free to use them. It seems to be the rule of thumb. Someone's going to prove me wrong and I'll get sued eventually, but that seems to be the general rule of thumb. So yeah, we do use transfer learning, and then also there are a few techniques that we found to essentially enable us to generate data that I think have really given us kind of an edge here. And it's not something that really needs hiding. So happy to give the details here. When you're tackling a problem with machine learning, your quantity and quality of data is everything, right? So oftentimes you will struggle to find a large amount of high quality data. And this is why the biggest and most successful players in the machine learning game are ones that are already gathering data from massive numbers of people through other means. So what we decided was, hey, what if we bootstrap a cheap machine learning based operation off of an expensive, difficult, kind of conventional operation. And then that's how we gather our data. So to give you an example, we were trying to learn kind of how to recognize biological samples and their level of growth using a camera that we have inside our lab robot, right? Now, the problem is that the lighting of the room changes very often. And someone can be standing somewhere casting shadows. These are things that for a human being would cause absolutely no problem at all. Like who cares, if it's an apple, then it doesn't matter if there's a shadow on it, it still looks like an apple. But for a lot of these image models, they can be really sensitive. So what we did is we set our lab robot. So first of all, we swapped out the lights with not Philips Hue, but a similar type of product. And then we basically connected to the API of the light and had the lights kind of randomly swap between a whole bunch of different lighting patterns. And then we had the robot take photos from all these different angles, kind of repetitively. And so the idea is we're essentially automating the room for the purpose of generating more data. And it's possible that there's some model, let's say, that already happens to be, better at seeing with, through shadows, or better at handling some of these, like weird, like randomness things that happens. If you can automate the environment to the point at which you can, manipulate the data to work, then oftentimes you can build a data set that's large and high quality enough that you can use it yourself. And by the way, we've also, we've been collecting, I think at this point, we're up to like 100,000 photos that we've collected using our lab robot, just by moving the camera around to get different angles of things and manipulating samples. We'll want it to be able to recognize a purple sample from a red sample. So we'll have the lab robot we'll tell it to mix up purple samples and red samples with different color mixes, and then go around them taking photos of them. So essentially we're training the thing to create the data and then gather the data. And this technique has proven to be able to kind of defeat deficiencies in data in a lot of cases.
Yeah, I'm sorry to cut you off, Tal, but we have another question. So can you wrap this one up?
Yes, I think we're about done.
Okay, cool. So there's a question in chat, and I'll rephrase it. So for the people who are interested in going into AI, so how would they go about learning it, and what are their prospects of getting a career in this field, especially when the competition has like PhDs and master degrees and literally specializing in AI? So how would they go about doing that?
Whoever asked that is a fantastic question, and you should have been first. So can you? Yes, you definitely can. How? So there are a few things that you can do to put yourself in a competitive place. First of all, understand what's going to be expected of you in the professional space, right? So people learning machine learning as like a hobby tend to focus on the models. The truth is there are a lot of skills outside the models that you also need to know, right? You need to have some sense of like the data wrangling. You should ideally have some degree of skill in data engineering so that you can, work with systems that companies have built up to move data back and forth. You're going to be expected to have skills in, sorry? Okay. You're going to be expected to have essentially a number of skills tertiary to this. And if you go back and learn those, you can assume that most students are not. And so as for getting ahead of students, skills outside of just the straight models is probably the best way to go. As far as being competitive against people who are currently in the industry, there are, I would say, strong indications at this point that you do not need a PhD in order to do applied work within machine learning. If you want to do research work within machine learning, like discovering the newest version of some model, leveraging we're not going to use the gradient, we're going to use the super duper gradient, a lot of this crazy academic stuff is restricted to academia and oftentimes at the doctorate and postdoc level. So yes, higher degrees are kind of needed for the research, but let's be honest, most of us aren't here for the research. You're here to do machine learning for some big tech company or something. For that purpose, yes. So I would focus on getting experience solving problems. Just like I would say to anyone who's prepping for a software engineering interview, do the leak code, do the leak code, do the leak code. For anyone who's prepping for data science, Kaggle, is get used to having problems that you're trying to solve and then solve them. And oftentimes a little bit of statistics expertise can be really helpful there as well. Finally, and I'm going to swap over to my kind of exit slide here, so that you guys have my information. I would say that it has become pretty clear that there are people coming out of boot camps that are competitive with people with PhDs in machine learning and data science. So it's not a thing that's necessarily impossible by any means. The biggest thing is experience, is dip your toes in and then pull your toes out and then jump the rest of you in and spend as much time working on this stuff as possible. Because to be entirely honest, on-the-job experience, for example, oftentimes includes fairly little actual work with models and a good bit of work on the data wrangling and all this other stuff. So it's not actually ridiculous to think that you can get more experience than someone who's on the job. just by focusing entirely on, you know, the juicy part of building the models. So, you know, that wasn't a complete answer, but in short, learn. So I guess 3 pieces of advice. One of them is learn the kind of tangentially related skills that are important, like data wrangling and so on, that don't involve actual model building and just like the machine learning stuff. 2 is you know, build as much experience as you can. And then 3 is target on specific skills, and don't just try to get better in general. Is have a way, and you know, what you do is up to you. It's something you have to discover, of identifying where you're deficient and then specifically target the areas of your deficiencies. I mean, that's more a lesson for learning in general, but especially when learning this stuff, I found to be extraordinarily helpful. And so those are kind of the 3 tips for, you know, for that question.
And to quickly wrap this up, one last question. For those who are interested in getting into AI, are there any resources that you would recommend to learn it that doesn't have a extremely mathematically treatment of machine learning?
Yeah. So Fast AI is pretty good. They're basically, understand, and I'll make this quick, but there's a trade-off that you should be aware of. And as long as you understand it, you can usually do pretty well here. The trade-off is between the kind of how useful is what you're learning versus how rigorous is it, call it that, right? Is on the one hand, you can go the academic route and learn, like, you know, exactly where all the partial derivatives go so that you can do this yourself, but oftentimes not necessarily have the ability to apply it. And you'll be much, much slower in learning how to actually use it. Or you can go the route of, and this is how I, you know, tend to teach this these days, of just saying, hey, look, it's a neural net. This is roughly what it's shaped like and how it works. Use this, you know, this library and it'll handle the math for you. And you can perfectly reasonably go to the point of being really, really productive in that way. So understand the trade-off between knowing all the math and being useful. The more math you know, generally the less useful you'll be in the same amount of learning time. So you can usually skip it. As far as those resources, so Fast AI is pretty good. There's like a whole education arm to Kaggle that has a lot of really, really good stuff. Some of it gets mathematical. Most of it is pretty good. If you're interested in the mathematical side, then I would say go for, so Andrew Ng's Coursera course is, you know, like, you know, the gold standard here. If you want to get a headache in 6 minutes or less, I would say it's, you know, beautiful, beautiful choice. He goes so deeply and thoroughly into the math. Like, you know, he literally wrote the book on this stuff, but of course that comes at a bit of a cost of usefulness. And then finally, don't discredit Medium and YouTube as really good sources. There's some people who make absolutely fantastic like representations of a lot of this stuff. Basically, you know, good teachers go to where the students are. And because so many people are flocking to YouTube and Medium, I would say that you can find absolutely fantastic, you know, lectures given by random people in front of a whiteboard, describing a lot of this stuff, doing a really, really good job at it. And those are also mostly the resources that I use myself. Hope that answers the question.
Cool. So we're out of time, but Tal and I will stay back here to answer any lingering questions. The other organizers will have to prep for the closing session. So if you have any other questions, you can stay back and ask. A quick note, just to plug DG, Tal teaches a machine learning group every Friday on DG. It's 2:30 to 4:30 usually. So yeah, you guys are free to leave now.
Yeah, and if you have any other questions, you can feel free to reach out at any of the resources on the screen. Usually I'm like reasonably quick to respond. And if you mention that you saw, like, you know, got my info from this event, then I should be a little faster to respond.
Hey, Tal, I have a question.
Can we stop the recording first?
Is it still possible to ask a question?
Yes, yes.
Okay, so just now you told me about the math aspect of learning AI. So I am a student who is like very interested in learning AI, right? But then I found most often that the limitations that we have when we're studying computer science in the university or college usually is because of the other subjects like math and physics. I have to admit that they're not easy course, and we need to spend time on them. And thus sometimes we don't really have time to hone our the skill that we want to learn. Let's say like the computer science aspect, for example, the AI itself. So at your level, how significant is mathematics? Like when I get to your level later on, like above there. Thank you.
Okay, so I think, so I'm going to divide the mathematics into two different, similar but definitely different kind of topics here. There's the math itself, and then there's the intuitions that you develop based on the math. I think that those intuitions are really, really helpful for pointing you in the right direction when you're trying to solve a problem. So, for example, you know, we'll be tuning a model for something, and then you just kind of get a sense of like, this is what this is doing to the data. You're going to need to do it that way, because you can feel, I don't want to call it the flow of information through the model, because you know, this isn't like a yoga retreat, but you can very much like kind of get a sense of what's going to act how and what's going to work and what's not going to. These are the intuitions that you build based on experience working with models, but they come a lot more efficiently if you have an understanding of the math. So for the purpose of learning those intuitions, I'd say the math is great if you have the time and the, you know, I guess another need to learn it. As far as how valuable is the math itself, not very. You very, very rarely, if ever, touch it directly. In fact, I would say that I spend so out of probably a 60-hour work week, and then maybe a 3-hour like, you know, machine learning lecture every Friday, I probably spend more time working with the actual math for the 3-hour lecture than I spend working during the 60-hour work week. And the reason is there's just libraries for all this stuff. You know, you very, very rarely have to touch it directly. And so if you don't want to have to sit through like, you know, a multivariable calculus class, and then a linear algebra class, and then, you know, the next level linear algebra class, and then, you know, something about like, you know, because someone's going to use the word eigenstates and like eigenvalues and expect you to understand that, you don't really need it to be able to do things productively. It's helpful, and it definitely speeds your process, but the math itself, you very rarely touch.
I see. Thank you very much for your answer, Tal.
Yeah, we have another question in chat. Emily has a question. I'm sorry I didn't pay attention to chat, but if you still have the question, you can unmute yourself and ask Tal.
Okay, thanks. No, it's okay. I already asked like 2 questions, so
Go ahead.
okay. Well, so I was wondering, I'm pretty new to neural networks, but if I have a data set, I want to be able to predict numbers to like 6 decimal points.
Mhm.
Like so far, all I've learned for multiple outputs for the output layer is like softmax regression. But I'm wondering, like, if you want to predict a specific number and not like a probability distribution between you know, like 10 numbers, how would you code your output layer? Like what would you use?
So you mean that instead of having a one-hot encoded output, you want it to just give you the number?
Yeah.
Okay.
Or
So
yeah.
that's what you really want to do here is don't add that to the model itself. Add it to, you know, like the Python script that's working with the model. And the reason why I say that is because there are connotations with like numbers that make it really, really hard for a neural network to learn that correctly. Essentially, when you're building a neural network, and if anyone could summarize, like, why do you build such complicated networks? Like, what does that give you? The truth is they really give you one thing, which is faster convergence, right? You are always going for faster convergence. Technically, even a small, I mean, there are cases in which you have a network so small that it can't learn something. But generally, given, you know, a functionally infinite amount of data, you can learn just about an infinite amount of patterns. But a better, more tuned network will converge faster. The problem is that if you, let's say are you by any chance working with MNIST? Is that what this is about?
No, it was my own data set from my dad's company. It was to
Okay.
play around with it, but that's what I would have needed to predict. It's like an efficiency of circuits.
Yeah, okay. So are you, that might change things slightly actually. Are you want the number out? I'm not entirely understanding the like what you're trying to build here. What is the input?
So the input, to be honest, it's like all these different properties of the circuits of each circuit, and it's like for a computer chip, like the distances between certain objects in the circuit, you know, how many nodes, it's things like that. And then it's supposed to predict the efficiency of the circuit, which usually my dad's company uses a simulation for it, but that's time consuming and costly. So I was trying to build a network that could just predict the efficiency. But so far I haven't really figured out like how I would create an output layer that would even be able to predict like a number, like
Oh,
20 decimal points.
okay. So I misunderstood what you were going for. Yeah. So if you just want a number, I would, so instead of, you can use like a sigmoid output if you want, for example, and then that'll give you something between like, you know, up to 1, and then you can scale that to whatever range you need. So if you have like a percentage or something, then scale that. That makes that version of the question is a lot faster, easier. So you can get a single number out, and in this case, it's actually quite sensible to do that. I'm not entirely, so what's in fact, so if you're using softmax right now, then what aren't you getting?
Well, no, I haven't used this data set. I've just been messing around with easier projects.
Mhm.
But I figured like I could only predict the first number after the decimal point. So you're saying that I could just have a single output and have it output the efficiency between 0 and 1?
Yes. Okay. So now I understand.
Okay.
So predicting the digits of a number is not really a good idea if you care about the quantity of the number. And here's what I mean. So let's say that you're trying to identify like numbers written down. In that case, the number isn't a quantity, it's a symbol to be identified, right? So in that case, doing something like one-hot encoding makes sense. If all you're trying to do is get out a number, like if you're looking for 8, 7.5 would be pretty close. 8.5 would be pretty close. And yet, how to put this, you're essentially adding in categorical differences where you're really looking for a regression kind of problem. You're treating a regression like a classification. So what I would do is say, you've got an output that scales from, let's say, 0 to 1 or -1 to 1. It depends on what you use. And then scale that to fill whatever, you know, if it's a percentage, then scale it up to 100%, right? And then sometimes there are other optimizations that you can use in here to be a bit better. So for example, if the numbers are usually between 90 and 100, then you can scale that out so that that's kind of the range that you're going with, so that you're filling the whole space available with the numbers that you have. The point being, don't go for predicting individual digits if you care about numbers as quantities, because it's going to make it really hard for your model to learn the differences between like 7.9 and 8, right? So think of it this way: if you're just looking at the digits, 7.9 and 8 are 2 digits off from each other, right? 7.9 and 8.0 are 2 digits off from each other because the 7 and the 0.9 are both wrong. On the other hand, 8 and 8.1 are only 1 digit off from each other, even though mathematically the error is the same, right? So you're introducing a kind of a bit of a bias here that you don't want to be introducing based on how you're doing that. So I wouldn't go for the digits. I'd go for spit out a single number and then scale that to fill the range you need.
So are you saying I could just have one output node? Like,
Are you only
And-
trying to predict one property of this thing?
I'm just trying to predict the number, like if the efficiency of a certain circuit, which would be one item in my data set, then it would be like, say I'm trying to predict the number 0.543 blah blah all the way to the 7th decimal point.
Mhm.
Can I just use like one node and have the
Sounds more
output?
like a regression task.
What was that?
Sounds more like a regression task.
Yeah, so it is a regression task. Yeah, you can use one output. So your 7 digits is going to be kind of hard. In fact, your 7 digits is going to be very hard. And I'll warn you also that I would think long and hard about the input that you use, because a circuit. So if, for example, you feed in an image of a circuit, then suddenly the thing has to learn two things. It has to learn how to predict the efficiency of circuits. It also has to learn how to recognize images of circuits, right?
Yeah, there's no pictures. It's just data about the circuit.
Okay. So provided that you're feeding it in a way that's easy to learn things from. And yeah, you can just use one number output and then scale it. I think you're going to really struggle again with 7 digits of 7 decimal places of accuracy, just because typically, based on how I'm envisioning you using this, you might need a very, very, very large amount of training to get it to that point.
Yeah. Okay. Yeah. You're probably right.
Is there a reason that it needs 7 digits? Or are you
Well,
using?
I guess
all
I could do less, but then it wouldn't be